Welcome to my channel Code with Ome. I'm Ome Chukwuemeka, and I'm making this video Bitcoin theory for my students in the NITDA Blockchain Scholarship program. And NITDA is National Information Technology Development Agency. So there's a program, it's a scholarship program going on, and I'm doing this specifically because my mentees in Ebonyi State requested for it. Okay, I did two previous videos, three actually. The one for GitHub, how to create a GitHub account, clone a repository, basically managing all your repositories in GitHub. And then I made a video on what's that again, on blockchain. What is blockchain? I have to explain the principles of blockchain. Now, to be able to follow me on this video tutorial I'm about to do, which is on Bitcoin theory, you need to go and watch what is blockchain, because I'm going to be using the concept I explained in that video to be able to work with to explain the material. So the material we have been given to work with is on fifth work. The course on fifth work, which is Bitcoin theory, is similar to this the Bitcoin white paper. Bitcoin white paper is just basically the same thing. Now, Bitcoin white paper is like those of you who did project work in the university will understand what it means to Bitcoin white paper is like a research paper on the Bitcoin, on the principles and concepts of Bitcoin. Bitcoin, like I said in the other previous video, Bitcoin is a digital currency, or let's say money that is digital. All right, so the Bitcoin white paper, which is just the course we are doing on fifth work, is the same thing. Okay, so it's just that there are some calculations you would have to do. I would show you how to do that, and then there are some also assessment on the platform. So follow me carefully. Make sure you subscribe to this channel, because I'll be uploading more videos to explain what you are being taught. When I upload the video, you get a notification. So turn on the notification bell on YouTube, and then you'll be able to follow me on the course. All right, now remember to also ask your questions at the comment section, and I will be able to answer you quickly. So make sure you watch the other video. Create a GitHub repository is also okay, but then make sure you watch the video on what is blockchain. I explained a lot of things there, so I wouldn't be doing those things here on this particular video. All right, I would want us to, I would prefer that we use this material, since this one, this material here is the same thing. Example, let's see. Okay, a messaging node. Let's see what messaging node is. For instance, you will see that messaging between nodes. Can we find it? You see, they said Bitcoin white paper. You see, so can we find it on the Bitcoin white paper? Let's see. Introduction, messaging between nodes. This time server. Let's see. This should be inside abstract. Okay, messages are broadcast on a best effort basis. So let's see, under abstract, I just want to show you. See here, look at it here. So messages are broadcast on a best effort basis, and nodes can leave and rejoin the network at will. So you see that is the same thing. Okay, so I would prefer we use this to explain it. So maybe peradventure, when trying to go through the course itself, do this course itself, you notice that there are some things that are here that are not on the course. Just call my attention to it in the comment section, and I will do a video on it. Okay, so we can be interchanging. Once in a while. So this is a research material, a research document. This Bitcoin white paper is a research document on Bitcoin. Remember that I said Bitcoin is money that is digital, while blockchain is the medium in which that digital money can be transferred from one individual to another, or from one person to another, or from one wallet to another wallet. Is the technology behind the transfer of this digital currency. All right, Now, I explained the concepts of blockchain in the previous video. You will need that information. So get on YouTube on my channel, Code with Ome, and you would find it. So let's move now. You see, Bitcoin, a peer-to-peer electronic cash system. Okay, now the abstract provides us an overview of the entire material, of the entire document we are working with. Provides us an overview of this whole stuff. Okay, so abstract, a purely peer-to-peer version of electronic cash. Remember I told you that Bitcoin is money that is digital. So it's telling us that it's a peer-to-peer version of electronic cash. What does peer-to-peer means? It means it's being sent from one individual to the other. Okay, so you say peer-to-peer version of electronic cash would allow online payments to be sent directly. Let me zoom this up a little bit. So yeah, let me see. Okay, I believe this should be better. No, it's too much. 150 is okay. Yeah. All right, so you could see a peer-to-peer version of electronic cash would allow online payment to be sent directly from one party to another without going through a financial institution. Remember I talked about third party in the blockchain. Okay, so the aim of blockchain is to eliminate this third party. I spoke about that there. Now, digital signatures provide part of the solution. So remember, they are telling us that Bitcoin is a kind of digital signatures. Remember I spoke about something about hashing, the 256 SHH hashing. More like hashing a text, converting that text into another text. I explained all these things in the blockchain. What is blockchain? So watch the video, you understand it better. So digital signatures provide part of the solution, but the main benefits are lost if a trusted third party is still required to prevent double spending. When there's a third party, you spend more. But when there's no third party, the aim of blockchain is to eliminate that third party. The third party, like we saw, is example, the banks or Western Union or MoneyGram. I explained how maybe you are receiving money from the United States into Ebonyi State, how it is done. The third party has to mediate that transaction. But blockchain aims at eliminating that third party and aims at making the transaction almost instant. If it was Western Union or MoneyGram or through domiciliary accounts, it takes like 5 working days for it to be processed. Sometimes it takes up to 2 weeks. All right. So what they are saying in this white paper is we propose a solution to the double spending problem, which is reducing the transaction amount that you have to pay using a peer-to-peer network. So understand this, we propose a solution to the double spending problem using a peer-to-peer network. Then, for instance, your uncle, like I said in the what is blockchain, your uncle may want to send you $20. Your uncle may end up spending almost $30, you see, just to send that money from US to Nigeria. So you need to understand that that's what blockchain is trying to eliminate. Now, the network timestamps transactions by hashing them into an ongoing chain of hashed-based proof of work. Remember I told you about what miners do, how they take each block of transaction, they have to find a key to be able to attach any transaction to the chain. All right, they have to find a key. So most of this concept here, I explained it on what is blockchain. So you need to watch that video over and over again, be able to understand what is going on here. So I wouldn't want to use the whiteboard for now because this white paper is specifically describing how blockchain is implemented in Bitcoin. All right, now take note of this, that the network timestamps transactions by hashing them into an ongoing chain of hashed based proof of work. Let me explain this. Forming a record that cannot be changed without redoing the proof of work. So in other words, remember I told you about the open ledger, how the open ledger came about, and then how blockchain had to switch from open ledger to distributed ledger. Watch what is blockchain. You need to watch that video. Okay, it's on my channel, Code with Ome. You will get this concept better. Now, the blocks, look at, we propose a solution to the double spending problem using a peer-to-peer network. The network timestamps transaction by hashing them into an ongoing chain of hash-based proof of work. So let me do some stuffs here. Remember, in what is blockchain, each transaction is recorded and a key is found to be able to attach another transaction by a miner. All right, so the miner does two things. It verifies a transaction and it has to find a random key to be able to attach this transaction to this block of transaction to the previous block of transaction. You understand? So, and that's where CPU power comes in. Somebody with a 2 gig RAM and somebody with another person with a 5 gig RAM will be competing on who will take that transaction and find this key that is hash-based proof of work. Hash-based proof of work, so that they can be able to link it to the previous block. So it forms a chain of transactions or chain of blocks or chain of proof of works. All right, so the first to find it gets an incentive, gets a reward, and that reward is Bitcoin, or that reward is money or digital currency, in this case Bitcoin. All right, so that is what this place is just trying to tell us, that the network timestamps transaction by hashing them into an ongoing chain of hash-based proof of work, forming a record that cannot be changed without redoing the proof of work. So by the time this transaction has been hashed and fixed here, it cannot be changed because it's a chain. That's why it's called blockchain. It cannot be changed unless you have to redo the entire transaction. Redoing it means you have to verify the transaction. One, you have to find a random key with which to chain it. That's just what is all about the proof of work. Okay, so and redoing it is impossible. Let me just put it that way, because it keeps following blocks and blocks and blocks, and different miners are also competing on who will be the first to find a random key. So the more CPU power you have, the more probability of you finding the random key with which to chain transactions in the entire peer-to-peer network of Bitcoin. All right. So if you look carefully here, you see, forming a record that cannot be changed without redoing the proof of work. The longest chain not only serves as proof of the sequence of events witnessed, but proof that it came from the largest pool of CPU power. Means that this chain can be as long as possible. All right, it just keeps going like that. Now you see, as you say, the longest chain not only serves as a proof of the sequence of events witnessed, means the transactions that are going on and being hashed and being chained to the block, okay, but proof that it came from the largest pool of CPU power. Means that as all miners are mining means verifying the transaction and finding the random key using an algorithm. Okay, so this is a proof of largest CPU power. Means there's a lot of miners doing this. Okay, we will begin to understand deeper once we begin to go deeper in this. You understand why this statement is so. Okay, prove that it came from the largest pool of CPU power, as long as a majority of CPU power is controlled by nodes that are not cooperating to attack the network. They will generate the longest chain and outpace attackers. Now what he's trying to say is this, just simple, that some people will try to create another chain which are attackers. Remember that miners are special nodes or special wallets or special blocks. No, not blocks now. Special nodes. All right. Your wallet address is a node. But then miners who verify transaction and then who find the random keys, they are special nodes. So once there's a large number of people using their CPU, their computer, to look for those random keys, they are called the legitimate node or the legitimate peer network. There are those who want to attack the chain, more like they want to now branch out, more like create another branch, maybe from here now, create another branch from here now, you see, and find the random keys. But then the CPU power of these attackers is nothing compared to the CPU power of the original ones. So by the time they try to create another attacking node, another attacking chain like this, These ones have larger CPU power, they will outpace it. Outpace it means they will verify more transactions quicker and faster than this one. And what will happen? Subsequently, this one will just vanish. The attacking node will just vanish. That's what he's trying to say here. Okay? But then we'll go in deeper steps. And you see, the longest chain not only serves as proof of the sequence of event witnessed, but proof that it came from the largest pool of CPU power, as long as the majority of CPU power is controlled by nodes that are not cooperating to attack the network. They will generate the longest chain and outpace attackers. The network itself requires minimal structure. Messages are broadcast on a best effort basis, and nodes can leave and rejoin the network at will. Remember, the nodes here are miners. Once a miner verifies a block of transaction and finds a random key and sends it to the network, it has to broadcast it to other miners so that they can put it in their own distributed ledger. All right? Now it says, and nodes can leave. A miner can leave the network and rejoin the network at will, accepting the longest proof of work chain as proof of what happened while they were gone. So the longest chain means that it has the longest CPU power. At some point, this particular one will just terminate, and then these transactions will just be moved into this longest chain because it has the largest CPU power. All right. So let's just go into more details now. Commerce on the internet has come to really rely almost exclusively on financial institutions, serving as trusted third parties to process electronic payments. You know this now. While the system works well enough for most transactions, it still suffers from the inherent weaknesses of the trust-based model. Remember that that's what blockchain aims at eliminating, this third party, this trusted third party. Completely non-reversible transactions are not really possible. Non-reversible transactions are not really possible. Means a transaction can be reversed. Okay, since financial institutions cannot avoid mediating disputes. You see, that's another problem it's creating also. Like, once money can be sent to Nigeria and then the person it's sent to maybe is not available to pick it up or doesn't have the necessary ID card to verify their identity to collect their money, what will happen? The transaction can be reversed back to the person. But then blockchain aims at making sure the money gets to the person without hassle, without issues, without the third party, without extra cost, and it has to be almost instant. Okay, the cost of mediation increases transaction costs. Means it increases the amount of sending that money to maybe Ebonyi State from US, for instance, limiting the minimum practical transaction size and cutting off the possibility for small casual transactions. And there is a broader cost in the loss of ability to make non-reversible payment for non-reversible services. You see, with the possibility of reversal, the need for trust spreads. That means once there's a reversal, there's need for reversal, then that means there's need for more trusted third party. All right. Now, merchants must be wary of their customers, hassling them for more information than they would otherwise need. A certain percentage of fraud is accepted as unavoidable. These costs and payment uncertainties can be avoided in person by using physical currencies. But no mechanism exists to make payments over a communication channel without a trusted third party. Remember, this is just basically explaining why they want to eliminate the trusted third party. Okay, it's just explaining it further. What is needed is an electronic payment system based on cryptographic proof instead of trust. Remember, cryptographic proof, like I explained, is maybe turning a text like this, Ebonyi .txt into a longer character based on this 256 SHA. Alright, remember that? Turning it into a longer character. Alright, using an algorithm. What's an algorithm? Using a kind of a piece of code to turn it into, to spread it. Spreading it into longer characters. It can turn Ebonyi into something random. Seriously random. I think I showed you guys that my database. I showed you something like that, random. Now, when you now look carefully, it says what is needed is an electronic payment system based on cryptographic proof instead of trust, allowing any two willing parties to transact directly with each other without the need for a trusted third party. Remember that? Transactions that are computationally impractical to reverse, you see, would protect sellers from fraud. Transactions that are computationally impractical to reverse, maybe that means transactions that cannot be reversed would protect sellers from fraud, and routine escrow mechanisms could easily be implemented to protect buyers. What is escrow mechanisms? Means sending the money into a base, or kind of sending the money into a wallet or into a network. Now, once the other party confirms the transaction, confirms it, the money enters their wallet. All right. Now, in this paper, we propose a solution to the double spending problem using a peer-to-peer distributed, you see now, distributed ledger now, that's what it just means, distributed timestamp server to generate computational proof of the chronological order of transactions. The system is secure as long as honest nodes collectively control more CPU power than any cooperating group of attacker nodes. That's just basically what it is. Introduction is over. All right. Now, transactions. Now, we define an electronic coin as a chain of digital signatures. Each owner transfers the coin to the next by digitally signing a hash of the previous transaction and the public key of the next owner, and adding this to the end of the coin, which is what I explained here. You're finding this key, this is a block of transaction. Okay, I explained this in what is blockchain. I'm just trying to link what I did in what is blockchain with this material. Then you can just, once you're reading it yourself, you'll grasp whatever the entire concept is all about. It's easy to understand if you pay attention. All right. Then it says, adding this to the end of the coin. That's what miners do. A payee can verify the signatures to verify the chain of ownership. You see here, transaction, owner's public key. Then this is the hash. This is owner one's public key. This is the hash, which is the key. Now, owner's zero signature. Now, this is a block of transaction. Now, it verifies it. Whichever miner is the first to verify it, you see verify here, becomes owner's signature. Then this is a transaction. Owner's 2 public key. This is owner's 1's private key. That key is a random number found using algorithm. The first to find it will chain the block of transaction into the chain. All right. Now you see it. The owner 1, who is the first to find it, will sign it. Another hash is there too. That's how it just continues. It just continues. Owner 3, owner 4, owner 5, owner 6. That is it until it gets to the current block. There's a current block now. I think the current block of Bitcoin should be over 2 million. Should be around 2 million blocks. It should be more than safe. The last time I checked, it should be almost, if I'm not mistaken, 2.9 million now at the block level, or it's more than. I may be wrong. It should be more than anyway, because Bitcoin started mining Bitcoin a long time ago. All right. Now the problem, of course, is the payee can't verify that one of the owners did not double spend the coin. Double spending means sending money that they don't have. I explained this in blockchain. That is the principle behind mining or minting, in which the miner has to verify that the person sending that money has enough money to be able to carry out that transaction. That's just double spending. So that's what it's all about. A common solution is to introduce a trusted central authority, or mint, that checks every transaction for double spending. After each transaction, the coin must be returned to the mint to issue a new coin. And only coins issued directly from the mint are trusted not to be double spent. That mint is created by those who created blockchain. That's another key, another principle now. What does it mean now? Let me explain. Remember that I told you that Bitcoin is digital money, or money that is digital. All right. So for a miner to verify a block of transaction, he has to first of all check that the person has enough money. Now that is at that point of checking, remember that that money doesn't exist anywhere. It's digital. It doesn't exist. It's not tangible. It's not physical. So we use physical money to exchange for digital money. That's where you buy coins. You buy Bitcoin. Okay. So from the code that was used to design Bitcoin will just create a particular number of coin for you that you are buying before sending it. Okay, so sending it to that mint means that okay, you have enough money. Just like printing money. Let me just use it that way. It's printing money. So you send it to CBN. Tell CBN you want to print $1 million. They will go and print it for you and give it to you. That's all. You now take it and begin to carry out the transaction. It's just that simple. All right. Now, where was I? The problem with this solution is that the fate of the entire money system. Okay. The coin must be returned to the mint to issue a new coin, and only coins issued directly from the mint are trusted not to be double spent. The problem with this solution is that the fate of the entire money system depends on the company running the mint. You see now, with every transaction having to go through them, just like a bank. You see now, and the blockchain aims at eliminating this. Anything third party, it wants to eliminate it. We need a way. You see now, we need a way for the payee to know that the previous owners did not sign any earlier transactions. For our purposes, the earliest transaction is the one that counts. So we don't care about later attempts to double spend. What does it mean? The creators of Bitcoin assigned a particular amount of money. It's called the Genesis block. The Genesis block that must be in circulation. That was the way they solved the problem of going back to the minting, or going back to the printing press, or whatever it is, to print more money. That was the way they solved it. So there's a Genesis block, which is the first block. This is the first block, and it's trusted. No other block can be added unless they want to upgrade the system to allocate more blocks. That's why you see some people doing airdrops on some crypto coins. They allocate it's called initial coin offering, ICO. All right, that was where they eliminated this. Now, for the purpose, the earliest transaction is the one that counts. Earliest is the one that counts, which is the one that was disbursed. So we don't care about later attempt to double spend. The only way to confirm the absence of a transaction is to be aware of all transactions, which is the ledger, distributed ledger. In the mint-based model, the mint was aware of all transactions and started with which arrived first. To accomplish this without a trusted third party, transactions must be publicly announced, and we need a system for participants to agree on a single history of the order in which they were received. That's the distributed ledger. The payee needs proof that at the time of each transaction, the majority of nodes agree it was the first received. That's just what distributed ledger is all about. The first person to find the key attaches the transaction to it. It's just the same thing. It's just that in this case, in this white paper, is now explained in greater detail. So you have to pay attention to the concept I explained in what is blockchain to be able to understand what this material is all about. Okay? Sorry, I'm having some catarrh. We're in the Hamatan season. So let's continue. Timestamp server. The solution we propose begins with a timestamp server. A timestamp server works by taking a hash of a block of items to be timestamped and widely publishing the hash, such as in a newspaper or Usenet posts. 2.5. The timestamp proves that the data must be existed at the time, obviously in order to get into the hash. Each timestamp includes the previous timestamp in its hash, forming a chain. That's just what I explained there. You find this key, you attach it. That's just what is. It's a network, remember, it's a server. But in this case, it doesn't store information. Like I explained in one of our online classes, it doesn't store information in a database. It just stores it in the network using IP addresses and stuff like that. All right. Each timestamp includes the previous timestamp in its hash, forming a chain with each additional timestamp reinforcing the ones before it. You see, this is the hash, this is the block. It defines it, it hashes it, it finds the key. This hash you are seeing is just key. It's just the random key. Hashing, cryptography. That's what's random key. It hashes it into the block transactions. Now, proof of work. To implement a distributed timestamp server on a peer-to-peer basis, we will need to use a proof of work system similar to Adam Back's hash cache. Okay, I want to stop here so that I can be able to do part 2 of this video tutorial. I don't want it to be too long because once it's too long, it takes time to upload. All right, so see you in part 2. Okay, so if you have questions in this one, I've explained from number 1, from abstract to number 3, then let me know. So I will break this video down to part 3, I think, or so. But just follow me. Make sure you subscribe to my channel to be able to follow along. So in the next video, we'll start from number 4. All right. Okay. Thank you.